Let me tell you about something that I've been putting a lot of thought into recently. That's localizing sound in a 3D space. Localizing sound just means that your brain can pinpoint a sound source as coming from a specific direction or location. The standard way of going about this with a mono sound source in mixing is using the pan pot. The pan pot lowers the volume of the left or the right channel, making it louder in one ear than the other, trying to trick your brain into thinking that the sound source is coming from that direction. The problem is, that's not how you really hear sounds in stereo. In the real world, if you hear something coming from your right, it's not generally that it's that much louder in your right ear than your left ear. It's that there's a difference of the sound's time of arrival between your two ears. Sound travels at a finite speed. That's about 340 meters per second, or 0.34 meters per millisecond. That means that if something's coming from your right, then it's going to hit your right ear a fraction of a second before it hits your left ear. It's not that it's that much louder in your right ear than it is your left ear. It's that there's a difference of the sound's time of arrival. So they try to solve this with matched stereo pairs of microphones. They'll use a left mic and a right mic and pan the left mic hard left, pan the right mic hard right, and this can simulate a sound being in a stereo environment. One of the most famous of these is the Decca tree, made in the early 1950s by Decca Records. There are 3 omnidirectional microphones, a left one, a right one, and a center one in front of the two. It's placed above the conductor's head, and the result is a stereo capture of a real 3D space with performers within it. So say you're in a room with an instrument here on the left, and you're listening here in the center. You have enough information with the X and Y coordinates to make a right triangle between the two, and you can find the distance between the instrument and yourself. Divide that distance by the speed of sound, and you have the time that it'll take for that sound to reach you. But almost as important as the time delays between the instrument and the listener are the earlier reflections of the room, which the brain uses to position the sound source within the context of the room. Well, we know that the sound will bounce off the wall, creating 2 similar right triangles. Let's assign some variables to these triangles, which I pulled right out of my ass. The hypotenuse of both triangles added together is the distance of the early reflection. And if we know the size of the room and our location within it, then we can figure out one side of the triangle, and with one side of each similar triangle, we can formulate the rest out. So in a room with an instrument and 3 microphones, then we'll need to calculate out 3 direct signals and 3 early reflections for each of the 4 different walls. But if all of the 15 discrete signals are the same volume, then it will really confuse the 3D space of the room. In the real world, sound dies as it travels. Because volume is logarithmic, it requires a reference distance and level in order to calculate out the absolute level at another distance. But if we make the sound relative to a 0 dB change at 1 meter, then we can make this a relative formula, and a change in sound pressure level or voltage based on that change of level. And so I programmed out a reactor ensemble to do all these calculations for me. Here I have a virtual stage with the Decca tree at 0, 0, and control over each of the 4 walls of the stage. From there, I can put any instrument at any point on this stage. And from that point, the plugin will calculate out the distance for each of the 15 discrete signals between the 3 direct signals and the 12 early reflections, the time that's required for the sound to travel each distance, and the change of volume that occurs over each distance. I have control over the volume of the early reflections as well to control how reflective I want the walls of my stage to be. Right now we have no early reflections. Now keep in mind that this drum loop that you're hearing now is both centered and mono before it runs into this ensemble. All the localization that you hear is due to differences of time of arrival with a little algorithmic volume change. You want to see what this ensemble looks like? And this is after I went through and organized it. So let's hear an entire orchestra placed on a 3D stage using these calculations.